I want to show you how to write atomic symbols, and to do that I've set up kind of a general display here. Here's my symbol for my element. Up in the top right, above it to the right, is the electric charge of that atom. Here's our atomic mass, and here's our atomic number. Just as a refresher, the atomic number is the number of protons. The atomic mass is the number of protons plus neutrons. And the electric charge depends on two things: the protons versus the electrons. In other words, positives versus negatives. If the two balance each other out, if they're equal, then we don't put a number here. So let me mess around with this. I'm going to use helium as an example. This is just from a periodic table somewhere. And these things, let's see, the atomic mass, protons plus neutrons, that's right here. 4.0026, that's an average, so there are some heavier heliums out there. We'll get to that in a minute. And the protons, that is right here. That's the atomic number. The symbol for helium is He. And electric charge, we'll get to that soon enough. Okay, so here we go. I want to construct an atom of helium here using my little icons. So here's a proton. We know we've got two of those, so let me bring in another one. Okay, and let's see here. So that's our atomic number is 2. We've got 2 protons. Then our atomic mass is, I'm going to say it's 4. I'm rounding it to 4 here. And protons plus neutrons equals 4. So if I've got 2 of these, that means I'm going to need 2 neutrons. So I'm going to drop 2 of those in here. And those are in the nucleus. So there's our nucleus. This is a helium nucleus. Okay. So the helium nucleus consists of 2 protons and 2 neutrons, or at least this one does. And then, typically, if it's not electrically charged, your helium atom will have 2 electrons. The electrons are these tiny little negative particle wave thingies that are all over the place around the outside. Sometimes you'll see them drawn like this, and sometimes you'll see them drawn as little dots everywhere, and sometimes you'll see them kind of as this fuzzy cloud that's everywhere. No matter how you think of it, this tool that I'm using, I think, is a good way for us to get an understanding of what's going on here. So let's do this. Here we go. Here's helium. Here's the symbol, He. Our atomic number is 2. We've got our 2 protons, so that goes down here. We've got 2 protons and 2 neutrons, so that means our mass is 4. And since we've got 2 minuses and 2 pluses, that means our electric charge is 0. So this is just a very simple way to draw it. But what if this electron right here left? What if it went away? What if some other atom grabbed it? Or what if we heated it up a lot, or we ran some electricity through it? So this electron leaves and just flies off. Well, now we have to worry about our electric charge, because now we've got 2 pluses and 1 minus. So when you add those all up, you wind up with a +1 charge. Okay? So sometimes electrons leave the nucleus. And sometimes actually an extra electron can come into an atom, can be attracted in. So in that case, this electric charge number would change again. So the way that I have it now is we've got 2 pluses and 3 minuses. So now we've got a -1 charge. So this number down here, the atomic number, is not going to change for an atom typically, because if that did change, it would be some other atom. The electric charge number, that can change quite readily sometimes. And what about the atomic mass? Can that ever change? Yes, it can. Some atoms are heavier and some are lighter. It's possible for a helium atom to have an extra neutron in there. If that happens, we know that it's still helium, because it's still got its 2 protons, but now it weighs 1, 2, 3, 4, 5. So this number would not be here. This would not be a 4. Our mass number would be 5. So just keep track of how these numbers can change, and you will be able to write atomic symbols pretty readily.